Hello, and once again, welcome to maybe the third class on atomic structure. We have completed the Planck's quantum theory, the atomic spectroscopy, and we are halfway, almost complete in the Bohr's atomic theory, hydrogen spectra, and the Bohr's atomic theory. We are almost 70% complete. But let's remind that in hydrogen spectrum, uh, all the lines in the Lyman series, they fall in the UV region and they involve transition from any higher cell to the first cell. 2 to 1, 2 to 1, 3 to 1, 4 to 1. This first line will be the transition from 2 to 1. Second line, 3 to 1. Third line, 4 to 1, and so on. And the last line will be the infinity to 1. So 1, the final, the source is infinity to 1. So I told you, when you find the lowest, and this is the order of decreasing wavelength. As the transition energy increases, however small it may be, it increases, lambda decreases. So the convergence, the overlapping occurs in the lowest wavelength region or higher energy region, lower wavelength region. And you can find out literally what is the shortest wavelength in that particular series by keeping E infinity as 0 minus kz square by n square. N is infinity, so 0. And since it is the Lyman series, so it has to come to the first cell, infinity to 1. So it is minus k. Z square is 1, so minus k. So simply it will be 0 minus k will be k. That will be equal to Sc by lambda. So we can find this lambda will be the shortest wavelength in that overlapping region, the last one. We can calculate. That I gave, this is the Lyman series. And what about Balmer series? N1 is how what and N2 are what? Yes? Arman, you
सर दे सर वो ମାନେ ବାମ ସିରିଜ ରେ ସେ 2 ରୁ 2 ଡେଷ୍ଟିନେସନ ହବ ମାନେ
N1 is
3 ରୁ
equal to
ସେ 3
N1.
to 2
No, 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 no. What are the variations? Which is fixed and which are variable? The lower, the destination cell, I'm talking of the emission spectrum. It has gone to higher level and now it will return back. So all the return journey from different higher cells to the second cell, that will produce lines in the hydrogen spectrum. All of them will be falling in the visible region. And that we collectively we call the series as the Balmer series. Balmer series. Yes? So N1 is equal to 2 and N2 will be what? N1 is the lower cell and N2 is higher cell. So what will be N2 values? Prabhu? Hmm? Yes? Hmm? Anyone?
Sir, 3, 4, 5.
Yes, 3, 4, 5, 6, up to infinity. So all transitions from any higher cell culminating in the second cell, 3 to 2, 4 to 2. We had seen in calculation 3 to 2. And we found it is 6,500 some angstrom. That is not only in the visible region, but also that is the orange region. And I had asked you to find out from 4 to 2, that is the second line. It will be coming 5,000 something. I didn't say you can find out that also. So Balmer series, the pattern is same. The gap will be reduced, and after few lines, the lines will overlap and form a thin band called continuum. And that Arohan was saying the last line will be at 3,000 something, infinity to 2. Infinity to 2. So k E2 is equal to minus k by 4. 2 square is 4. And E infinity is 0. So it is the difference is delta E is equal to plus k by 4. Empty kartila to? Empty kartila? Did you do this in this way?
Yes, sir.
Which is SC by lambda. So here lambda will give you the shortest wavelength here, which he found to be 3,900. How much you got? Hmm? You told something, some value you told 3,000.
3646.
So it is almost in the UV region, in the last part of UV region. We take the range. It's not hard and fast, exact. So it is in the borderline. It is in the borderline, and strictly speaking, it will be falling in the UV region, the last part of UV region, because we have started our visible 3,800 to 7,600. So if you take that range as visible, so it is falling in the UV region, doesn't matter. But that is the wavelength. So similarly, in the Paschen series, tell me what is the destination cell, because we are all talking in terms of emission spectrum. It will go, it has gone already there in different higher states by absorbing different quanta or different photons of energy. They are there, but now they will be transiting from higher cells to lower cell, emitting photons, and that will be recorded as lines in the spectrum. So tell me, what is the lower cell and what are the different higher cells?
So lower cell is 3.
And higher cell?
Sir, 4, 5, 6 up to
And
infinity.
yes. So the first line will be from 4 to 3. Second line, 4, 5 to 3, all three. Third line, 6 to 3, all three. So they will be falling in which region? This will be falling in the visible region. And all these lines will be falling in which region? This Paschen series. Yes, Prabhu?
Sir, near infrared region.
Yes, in the first part of the infrared. What is the range of infrared? Can you tell me the approximate range of infrared radiations? Yes, anyone can intervene and say. It is 7,600 angstrom, the end of visible, to a very high value, 6 times 10 to the power 6 angstrom. So the range is very big. So the first part of IR region will be the Paschen series. And the second part is the bracket series. Sorry, P-Fund series. Then the third part is brackets. You know, the Paschen, after Paschen, which series comes?
Sir, bracket series.
Bracket. So n is equal to 4 and higher cells are 5, 6, 7, 8 or to infinity. So, and similarly, the P-Fund series, the n is equal to 5, n1, and n2 is equal to 6, 7, 8, 9. And similarly, the Humphreys, the last series, invented. so far discovered is N1 is equal to 6, N2 7, 8, 9, 10 and all. So if I ask you a question, question number 1, what transition of electron gives the first line of Paschen series? Yes. Answer it, Prabhu.
Sir, 5 to 4.
5 to 4. Yes, Arman. I told you that Paschen series, the destination is 3, always 3. How it became 4 is very surprising. Arman? Arman?
Sir, sorry, sir, 5 to 3.
Oh, you answered. Arhan, you
Yes,
answered.
yes, sir.
Oh, sorry, I thought Prabhu. Okay, since you are looking to past tense means immediately you are struck with 3. Balmer means it is 2. Lyman means 1.
Yes,
Bracket
sir.
means 4. Pford means 5. So once I say past tense, then 3 will come to your mind. All will be returning to 3. So first line means it is the next higher state, that is 4 to 3. Answer is 4 to 3. Let me ask you another question. So what transition gives the third line of Lyman series? Yes, Prabhu, you are opening your microphone, but no voice is coming.
Sir, 6 to 3.
Sir, 4 to 1.
Precisely. Because Lyman means the destination is 1. So it will come to 1. Then only Lyman. Then only visible. Sorry, UV. All of the lines will be coming in UV. And that series is called Lyman. So you just think the first line is for 2 to 1, second line is 3 to 1, definitely third line will be 4 to 1. You just try the analysis, the deduction. 2 to 1 will give you the first line, 3 to 1 will give you the second line, so the third line will be 4 to 1, so this will be 4 to 1. And so what is the second line of Balmer series? Which transition?
Sir,
Prabhu, you
4,
are huh?
sir, 4 to 3.
ତମେ ନିଦ ସବୁ ଭାଙ୍ଗିନି. That is precisely the conclusion that I can make now. You are not fully awake. Yes, Arman? Arohan? Balmer series. Hmm? Balmer series.
5 to 2.
Oh my God, this. So the correct answer is from 4 to 2. The first line is from 3 to 2. The destination is always 2. The second line is 4 to 2. The third line, because I have asked second line, so it will be 4 to 2. Now, can you find me? I would have bypassed this time that I am spending now in revising the hydrogen spectrum. I would have saved time. So can you find that the lambda for the first line of Paschen series? A bit of calculation. 2 So what is the transition for the first line?
2 to 1.
Sir, 4 to 3.
Sir,
Sir,
pass.
4 to 3.
Passion is not Lyman. See, that's the reason
Sorry,
why
sir.
I'm repeatedly saying that you are not fully awake. Passion is 3. And you are such good guys, I know, Prabhu. You are such a wonderful guy. And you are not able to remember this that Passion is 3, Balmer is 2, Lyman is 1. Oh, forget about bracket. Bracket is 4, P fund is 5. This much you can't remember. So many times I'm saying, not once. So it is 4 to 3.
Yes,
So
sir.
by K method, if you do, then it is E4 is minus K, Z is 1 for hydrogen. So it is K by 16 and is K by 9. So the difference is always positive. Delta E is E4 minus E3 minus K by 16 plus K by 9. So the LCM is, I am doing the sum. You are not doing. Because my interest is to save time. And I cannot go beyond 1.5 hours max. Less than that is better. So this will be how
So
much?
18750 angstrom.
No, it is how much? 7K, right? 7K by 144. Is it correct?
Yes, sir.
That is equal to SC by lambda. Then you have to find out. So K value is how much? 2.18 into 10 to the power minus, say, we take joule per atom. 6.626 10 to the power minus 34 joule second to 3 into 10 to the power 8 and lambda. So whatever lambda we get, that is in meter. So that there's x. So x multiplied by 10 to the power 10, that becomes angstrom. Because 1 meter is 10 to the 10 angstrom. So what is the angstrom value that you got?
So 18750.
So definitely this is believed to be correct because it is falling in the IR region. IR region starts from 7,600 to very high, 6 into 10 to the power 6. So you, Prabhu, check whether Arohan's answer is correct or not. He is saying it is 18,750. What you got? Okay, you check it. Now we can put it in another format. That will be easier for you to calculate. Instead of K format, you can have a Ries equation, RITZ. So there is a general equation to find out the lambda or the nu bar web number for any line of any series. It is a simple equation that supposing the lowest, the destination, the lower cell is minus K Z square by N1 square and the starting cell, the higher cell N2 is equal to minus kz square N2 square. So in general, the difference will be equal to, if you take common, this becomes plus. So kz square we take common and it becomes 1 by N1 square minus 1 by N2 square because this becomes plus. This minus this. So this become plus. I have kept it in the beginning. So it is 1 by N1 square minus 1 by N2 square. So N1 is any lower cell, the quantum number of the lower cell, N2, the principal quantum number of lower cell, N2, the principal quantum number of any higher cell. PQN is principal quantum number, the cell number 1, 2, 3, 4. So if you write in place of del E as HC nu bar, which Rees did. He made an equation involving wave number. Wave number is equal to this much. So bringing HC to the other side, nu bar, the wave number is equal to K by HC Z square. And this is a constant called R, a Rydberg constant. Rydberg, not Ridge. Equation was Ridge equation, but the constant was given long before Ridge. That is the Rydberg constant. So this is the Ridge equation. But this constant R is called the Rydberg constant, which is equal to K by Hc, which is a constant. And the value is in 108699 centimeter inverse, or make another two zeros, 1.086 into 10 to the power 7, another two zeros, a meter inverse. 1, 2, 3, 4, 5. Another two zeros means 7. Okay. 1.086 into 10 to the power 7 meter inverse, or 109, not 108. I'm so sorry. This is 109677. So this is 109. So this is the value of a Rydberg constant. 109677 centimeter inverse. So the value will be given in your question. It may be sometimes it is given 700 something. Whatever value is given in the question paper, you use that, or else you remember this 109677 centimeter inverse, or 1 point the same thing times 10 to the power 7 meter inverse. So this equation can be easily, or if you use in place of daily, if you use h nu, directly h nu, it will be kz square 1 by n1 square by n2 square, and then nu is equal to nu. This is frequency. K, simply k by h. And supposing somebody will ask you, find the frequency, then this k by z is 3.29 into 10 to the power 15 hertz. This is the constant. The name, there is no name to this constant, but 3.29 into 10 to the power 15 hertz. This is the value of the constant. So if you use this equation, I ask you to find lambda for the say third line of Lyman series. So you can use this equation. First find nu bar, then find its reciprocal. Because I am asking you to find lambda, not nu bar. Nu bar, that is wave number and wavelength, they are reciprocals of each other. So you use the famous Ridge equation, nu bar is equal to R Z square is equal to 1 for hydrogen atom. No, let us, okay, no, let us do it like this. N1 square minus 1 by N2 square. So 109677, I'm using CGS centimeter inverse. Z is 1, and this is the third line. So the destination cell will be 1, and you make a deduction 2 to 1, first line, 3 to 1, second line, 4 to 1, third line. So this will be 4 square. So this is centimeter inverse. So So immediately here you can make a change. So lambda is equal to 1 by nu bar, just reciprocal of this, 16 by 109,677 into 15. You make a reciprocal of this, become 16 by this into this centimeter, and immediately multiply 10 to the power 8 and make it angstrom, because we are having centimeter. 1 centimeter is 10 to the power 8 angstrom. So you can find out something which value, I think it will be 900 something. Can you find it for me? This is 16 by 1.0967, taking 3 significant digit into 15, 10 to the 5. So this becomes 10 to the 3. Use your calculator and tell me what is the wavelength in angstrom for the third Lyman line, the third line in the Lyman series. Be quick.
Sir, nearly 972.55 angstrom.
9.
72.55.
So you got the same value, Prabhu? 972.55
angstrom.
Did you get the same value? It will be 900. I knew it will be 900 something, because the starting was 1025. What you told, I don't remember what you told, but the first line we calculated last time for the Lyman series, it was 1025 or something like that. This is the first line, 2 to 1. Then 3 to 1 will be the second line. That will be some same 900 something. 4 to 1, the third line, same 900 something. How much you got, Prabhu? I remember what we did.
It is correct. Just 97
कितने भरला?
97.2
Huh? 900?
972 Armstrong.
972 भरुଛି.
Yes, sir.
First exercise. ଏଇଟା ଆମେ ବାହାର କରିଥିଲେ, ଏଇଟା ବାହାରିଥିଲେ, ହଁ, sorry, it's not 1025, it is 1215 angstrom, the first line. I am so sorry. The second line will be 1025, yes, which you did, right? Arohan, I think you told the answer 1000 something.
Yes, sir.
That is the second line. First line is 1215, and as Prabhu claims that it is 900, kitna, Prabhu?
972.55 Armstrong.
Say allowed. Same value, almost same. डेसिमाल पॉइंट रे एपट सेपट हम तुम केते प्लेस डेसिमाल को जाउछ, सिग्निफिकेंट डिजिट केते नउछ, गोटे प्लेस ऑफ डेसिमाल नउछ ना तीनटा नउछ, सेही अनुसार the answers might be slightly different, but 972 बाहर ना नहीं.
Yes, sir. Yes, sir.
So you can use this equation very confidently. First find nu bar and then lambda, a reciprocal of that. You can directly solve. If you may not use this equation, this 3.29 into 10 to the 15. Oh, this one. Oh, where? Yes. Only when, oh, I'm so sorry. This is not nu bar. This is new. This is new. Only when you are asked to find frequency, then you can directly use 3.29 10 to the 15. Or you can find nu bar and correlate between nu bar and nu, because nu is equal to c by lambda. So 1 by lambda is equal to nu bar. So nu is equal to c into nu bar. So once you find nu bar, you can also find nu is equal to c nu bar. So simply multiply c with nu bar, you get nu. So I usually ask students to avoid this, because they may confuse the equation to be nu bar is equal to c nu, but actually nu is equal to c nu bar. So instead of doing that, first find, if you are asked nu, you use this equation. If we are asked to find nu bar, already there in the Ridge equation directly. If you are asked lambda, then you make a reciprocal of nu bar so that you get lambda. So, so can you find out a question? What lambda in the line for electron of He plus to transit from 3 to 2? So far, we have been doing hydrogen spectrum. But as I told you, that Bohr theory is not only applicable to hydrogen, but also other one electron species like He plus, like Li2 plus, like Be3 plus. So we can only change Z. The Z square term is there. So we make it 2 square. So we can use the Ries equation that nu bar is equal to R Z square, because Z square term is there in the Ries equation. R Z square. We were taking it as 1 for hydrogen. But if it is helium plus spectrum, then helium in the Tommy it has 2 protons. So this will be 109677. Z is 2 square, and the transition is from 3 to 2. The lower one is 2 and the higher one is 3. So definitely it will be much lesser wavelength than the first line of the Balmer series of hydrogen spectrum, because there was no 4 here, it was 1. So since 4 is there, the nu bar will be more, the energy will be more, nu will be more, lambda will be less. So the corresponding lambda will be less. It will not fall, as I am inclined to believe, in the visible region. Instead, it will fall in the UV region. We may not call it a Balmer series, because Balmer series, Paschen series, these are named for hydrogen spectrum. But the equivalent line of the Balmer series in He plus will not fall in the visible region. In some questions you may find what is the wavelength of the first line of the Balmer series for He plus spectrum. So they give the same name for other species, but actually those names are meant for hydrogen spectrum. Therefore, I didn't use the term Balmer here. Instead, I said what will be the lambda for the line which you get in the He plus spectrum in the transition from third cell to second cell, which is equivalent of the first line of the Balmer series in hydrogen spectrum. So how much you got? So only 4 will be here. This will be 4, this will be 9, this is 36, this is
So
5.
5 by 36.
Yes. Then you make a reciprocal lambda is equal to 36 by 109677 into 4 into 5, and make it 10 to 10 to the 8 angstrom immediately, because this is centimeter per 8. So you can get this, I think, will be less than 3800. It will be falling in the UV region, because it's not hydrogen. Tommy has more number of protons, 2 protons, so attraction will be more. So the energy difference will be more. Hence, nu bar will be more, lambda will be less.
1640.3 Armstrong.
कहते 1000
1640.3
40 point.
Armstrong.
Maybe if this comes same, then this 0.3 might be 0.2, doesn't matter. Arun, did you solve this?
Sir, 1 second, sir.
This is not falling in the visible region. It is falling in the UV region. But the corresponding counterpart in the hydrogen spectrum was falling in the visible. We got it 6500 something in the orange region. in the visible region. But here, since it is 2 protons in the atomy, the attraction force is more, attraction is more, so the energy difference will be more. Shaya bharla?
Again, sir.
Okay. Now, I think we have done sufficient justice to this spectrum. Now, before we go and a bit of revision for the derivation part of the energy equation, we have not done. Only radius, up to radius we have done. Let me ask you, in terms of K, 2.18 into 10 to the power minus 18 joule per atom. You answer this. So if for hydrogen atom, so the energy of the electron in the first cell, this is the n is equal to 1. I am not saying K cell. There will be confusion because the constant is K. So if I say K element, then for the K there will be a confusion. Which K I am talking of, the constant K or the K cell? So n is equal to 1, this is 2, 3, 4. So the first cell, the energy is minus K. We will know today why the energy is minus. The absolute energy value is minus. We'll know today. In the derivation, it will come. And here, if it goes to the second cell, same electron will now possess minus K by 4. I'm talking of hydrogen. If it is He plus, then 4 times 4K. This is because Z square, this is 4 get cancelled, minus K. So whatever is the energy value of electron in the first cell of hydrogen atom, same will be the energy value in He plus if it remains in the second cell. And this will be minus K by 9. I'm talking of hydrogen. This is minus K by 16 and so on. Now my question is, supposing this electron, which was there in the ground state, will be going to the infinite distance. That means ionization will occur. When we say that the electron is going to infinite distance, we mean that it will not come back. It has gone forever. So hydrogen has turned into hydrogen ion. So that is called the ionization energy. So what will be the ionization energy for hydrogen atom? When the energy which is required to remove the electron from the ground state to infinite distance, it will not come. When it goes out of the electric field of the nucleus, so it is gone forever. And ionization has happened. Tell me, put your mind and tell me, in terms of K. Now, this is the concept. While bringing the electron from infinite distance, with more and more attraction will happen, and while it will settle down in the ground state in the first cell, then it has lost, overall it has lost K quantity of energy. Since it has lost K quantity of energy, its energy value is minus K. Just like in electric potential that you have done in your class 10 in my camps. So infinite distance, it is taken to be 0. The energy of the electron is taken to be 0. As you draw the electron closer and closer to the nucleus, it will lose energy due to attraction. And as much of energy it will lose, its energy value will be minus that. If you have brought it to the second cell, by that time it has lost K by 4 quantity of energy. Therefore, its energy is minus K by 4. And when it bring it to the ground state, Lakshman Rekha, it has lost K quantity of energy. Hence, its energy value is minus K. Minus represents how much of energy it has lost. In fact, its potential energy. Of course, kinetic is included, but including kinetic which is positive, the negative का पल्ला भारी है, तो इसीलिए minus K is the energy that includes kinetic. But we are explaining in terms of potential energy, but kinetic energy is also involved because it is moving, having some kinetic energy, which is positive. But since the potential energy is double the kinetic energy in magnitude, but negative in sign because it is a loss. There is potential. The energy is being stored. And when you want to dislodge the electron from the first cell to the infinite distance, you have to apply the same quantity of energy as it is carrying. Now it is carrying minus k. So you give plus k. So it will be dislodged. Second को जीवन third second को जीवा को हेले difference energy कहते ना minus k by 4 minus k 3k by 4 देले से second को जीवो 8k by 9 देले से third को जीवो. So that you have to calculate the difference between the lower cell and higher cell and lower cell. That much of energy corresponding photon it will need for jumping from one cell to the other. But for infinite distance, plus of the energy of that cell, because the energy of the energy of the electron in infinite distance is 0. Minus k by infinity square is 0. So whatever is the energy value, just remove minus sign, make it plus. That will be the energy required. Supposing second re thila, it wants to go to infinite distance. Aguru tak pathai deicho. 3k by 4 deikri pathai deicho. And now you want to send it to the infinite distance. So it will need k by 4 now. Because already 3k by 4 you have already given. Now its energy is minus k by 4. So plus k by 4. It will, if it will take, then it will go to infinite distance. Now, ionization energy is calculated from the ground state. So whatever is the ground state energy value, just make it plus. So K. So this is 2.18 into 10 to the power minus 18 joule per atom. But if somebody will ask you what is the ionization energy of hydrogen per mole, so then IE per mole, then you have to multiply this constant with Avogadro's constant 6.022 10 to the power 23, then that will become equal to, you calculate it will be 1300 some 13,000 joules per mole, and if you convert to kilojoules 1313 kilojoules per mole. कौन कहूतला?
Yes, sir. 1312 kilojoule per mole.
हाँ, से 12. Okay. मन रखिए आपको मोड कर दीजिए. So let it be 12. So for this is kilojoules per mole. But for calculation, we don't need per mole, we per atom. Per atom, it is this much. For all calculations in Bohr's theory, we don't take per mole data. Either we take 2.18 10 to the minus 18 or 13.6 electron volt. Now, I have a question. Supposing we are considering He plus, already the first electron is already knocked out, then only it will agree to Bohr's theory. So first ionization energy, it has got two, helium atom has two ionization energy. First ionization energy is the energy required to remove the first electron out of the two electrons to infinite distance. Energy cannot be found out by Bohr's theory. सेटा periodic classification पढ़ा ले जानी परिबो सेटा केमती बाहर करा जाए. He atom taku He monopositive ion karibo by knocking out one electron. This is called the first ionization energy IE1. जोटा तुम्हें Bohr theory बाहर करी पारिबो नहीं. Only when it becomes a one electron species like hydrogen, then you can do. He plus ru जो गोटे इलेक्ट्रॉन रही ताकू बाहर करिया पई दो दरकार सेकेंड आयोनाइजेशन एनर्जी कार हाइड्रोजन एटम रो सेकेंड आयोनाइजेशन एनर्जी सॉरी हीलियम एटम रो सेकेंड आयोनाइजेशन एनर्जी बाहर करि पारिबो He डबल प्लस करिया पई. तो माय क्वेश्चन नाउ इज जो व्हाट इज द सेकेंड आयोनाइजेशन एनर्जी question hala, what is, or to be very crude, what is energy required to convert He plus G to He double plus Z, which is nothing but second ionization energy of helium atom. Tell me, what is the energy required to convert He plus to He double plus? That means to remove the only electron present in He plus from the first cell to the infinite distance. You answer in terms of K. You need not calculate. I don't need you to calculate. This is a very simple thinking. It's not a big deal. I've already told you several times the concept. You answer in terms of K.
Sir, 5248 000 joules
No,
per
no, no.
minute.
Aaron, I don't need this, the numeric value or the calculated value. I need you to answer in terms of K, the constant, 2.18 times 10 to the minus 18. K. Now, K টা answer dela, Prabhu,
No, sir.
Aaron. Calculation ମୋର ଦରକାର ନାହିଁ. I need ଯେମିତି ଏଟା K ହେଲା. यार answer
Elder.
ହେଲା. ହଁ.
Sir, it is 4K.
Yes, precisely 4K. କାହିଁକି ନା helium plus ର ଯେକୌଣସି ଏନର୍ଜି ହେଉଛି ମାଇନସ୍ କେ ବାଇ ଜେଡ୍ ସ୍କୋୟାର ମାଇନସ୍ କେ ଜେଡ୍ ସ୍କୋୟାର ବାଇ ଏନ୍ ସ୍କୋୟାର. ଏଇଟା ହେଉଛି ଏନର୍ଜିର ଫର୍ମୁଲା ଫର୍ ଏନି ୱାନ୍ ଇଲେକ୍ଟ୍ରନ୍ ସିଷ୍ଟମ. ସୋ ଜେଡ୍ ସ୍କୋୟାର ଉପରେ ଅଛି. ସୋ ହିଲିୟମ ପେଟରେ ଦିଟା ପ୍ରୋଟନ୍, ସୋ 4 2 ସ୍କୋୟାର, ସୋ 4K. ଆଉ ଫାର୍ଷ୍ଟ ସେଲ୍ ଯେହେତୁ ଗ୍ରାଉଣ୍ଡ ଷ୍ଟେଟ୍ରୁ ବାହାର କରାଯାଏ, ତେଣୁ ଏଠି 1 ସ୍କୋୟାର. So minus 4K is the energy of the electron in He plus in the first cell, in the ground state. ସେଇଟାକୁ ଯଦି ଇନଫାଇନାଇଟ୍ ଡିଷ୍ଟାନ୍ସକୁ ପଠେଇବ ତାହେଲେ IE2 ଯାହା ନାଁ ଦେଇଛେ ଆମେ IE2, ସେଇଟା ହିଲିୟମ ଆଟମର IE2 ବା ଏନର୍ଜି ରିକ୍ୱାର୍ଡ from the first cell to infinite cell will be equal to plus 4K. This plus 4K କୁ ଯଦି ତୁମେ ଏନର୍ଜି କାଲକୁଲେଟ୍ କରିବ, 4 into 2.18 into minus 18 joule per one atom, or this is the ion, 1 He plus, and for mole it will be again Avogadro's constant times that value. I'm not asking that. I'm asking in terms of K. 4K will be the energy required to shunt out the electron, the only electron present in He plus, from the ground state to the infinite distance or infinite, so that you convert He plus to He double plus. That is why it is called the second ionization energy of helium atom. First ionization energy, Bohr's theory cannot give. You have to adopt another technique to know what is the energy required for the first ionization energy. Moment it becomes one electron species, Bohr's theory is applicable and you can find out. So, tell me another question. What is the energy required for converting Li double plus to Li triple plus? That is, lithium has 3 electrons. So the first and second ionization energy cannot be found out by Bohr's theory. That I will provide you. First IE and second IE cannot be found out. I'm not asking you that question. I'm asking, already theta electron golani. We have converted lithium atom into one electron species Li double plus. Now you will be applying Bohr's theory. By using Bohr's theory, you can very accurately predict what will be the third ionization energy, cannot be found out by Bohr's theory. But the third ionization energy can be found out. Kete? How much?
It is 9K.
Definitely 9K. So why are you asking in this mode, which I usually detest? I shared with you my test. The answer you are giving, why you are giving it in a question mode, as if you are asking me a question. 9K? Instead of in
Sir,
this
I am
mode, no, let me tell you, in not only to me, but also to any teacher, instead of answering in a answer mode, 9K, sir, 9K. Because you are giving an answer. Oh, sir will say, no, this is wrong. You recalculate. 9K? You are asking again to the teacher that will it be 9K? You confirm. That means you are putting another question to your teacher. So don't do
no.
that.
Sorry, sir.
Sorry, sir.
So particularly I don't test it. That's why I'm saying it. So it will be because is minus energy of any one electron species is minus kz square by n square. So ground state n is equal to 1. So minus k, this is 3 square because lithium has atomic number 3. So minus 9k is the ground state energy of the electron in Li double plus. Already 2 electrons gone. So that solitary electron to be removed, that is called the third ionization energy of lithium atom. Or we can say the energy required to convert. ପ୍ରଭୁ ତମ ମାଇକ୍ରୋଫୋନଟା ବନ୍ଦ କର, ଗଡ଼ଗଡ଼ ହେଉଛି, ଯେତେବେଳେ କହିବ ସେତେବେଳେ ଓପନ କର. Li double plus is converted to Li triple plus. The energy required is plus 9K. So answer is third ionization energy is whichever I am asking, this same thing as IE3 is plus 9K. You got it? Arun Bujilo?
Yes, sir.
And Arman?
Yes, sir.
Then you apply, you put the value of Ka and then calculate per species Li double, per one ion Li double plus. And for Avogadro's, for 1 mole, you multiply. Okay. Then coming back to the derivation part, and we were doing in SI system, I once again tell you the nucleus contains Jd charge. Z can be 1 for hydrogen, 2 for helium plus, 3 for Li double plus, 4 for B triple plus. So this, and only 1 electron is there in the ground state. It can go to different higher levels. We don't bother. We are just calculating the energy value. So this is R. And we equated the centripetal force with centrifugal force. The centripetal force is the Coulombic force of attraction, 1 by 4 pi epsilon naught Zd square, Zd into E, Q dash. The protonic charge and the electronic charge, Zd square by R square. This is Coulomb's law. And we equated to centrifugal force mv square by R. This is for all centrifugal force, whether it is attracted by any electric field or magnetic field or gravitational field. For all of them, the centrifugal force, which is wanting to take it away, is mv square by R. And from this, we got mv square. 1 R get cancelled, is 1 by 4 pi epsilon naught Z square by mr. Not mr, only R, Z square by R. Right? Yes or no?
Yes, sir.
And then this is equation 1. We also got V square equal to 1 by 4 pi epsilon naught Z square by mr. Then we took the Bohr's postulate about the quantization of angular momentum. mvr is equal to nh by 2 pi. So from there we found V is equal to nh by 2 pi mr. Then we made a square of it. And we made a square of it. And we equated this equation from centripetal, this equation 2 with this Bohr theory. This is the general centripetal V square, and this is from the Bohr's postulates. So if we equate that, 1 by 4 pi epsilon naught Z square by mr is equal to n square h square by 4 pi square m square r square, we got the value of r. 1 r got cancelled, and finally we got 1 r. 4 କଣ ଏଠି ଥିଲା ସେଠି ଥିଲା, ଦେଖିଲ 4 cancel ହେଇଗଲା କି?
Yes, sir.
ଗୋଟେ ପାଇ ରହିଲା. ସୋ r ଟା କେତେ ବାହାର ଥିଲା? n square, ଆଉ ଗୋଟେ କଣ କଟିଲା, କଣ m ଗୋଟେ କଟିଗଲା. ସୋ n square h square by z e square, ଗୋଟେ ପାଇ ଏଠି ରହିଲା, ଆଉ କଣ ରହିଲା? m ଗୋଟେ ରହିଲା, m ଗୋଟେ ପାଇ ଗୋଟେ ରହିଲା, r ଟା ସେପଟକୁ ଗଲା, z ସ୍କୋୟାର ଟା ତଳକୁ ଆସିଲା, n ସ୍କୋୟାର ଏତିକି ତ, ଆଉ କଣ? ଆଉ ନା ଆଉ କଣ ରହିଲା ଦେଖିଲ?
Sir, no, sir.
ସୋ ଆମେ ଯଦି କନଷ୍ଟାଣ୍ଟ ଟର୍ମଟାକୁ ଅଲଗା କରିଦେବା, h ସ୍କୋୟାର ଇଜ କନଷ୍ଟାଣ୍ଟ, e ସ୍କୋୟାର ଇଜ କନଷ୍ଟାଣ୍ଟ, ପାଇ ଇଜ କନଷ୍ଟାଣ୍ଟ, ମାସ୍ ଇଜ କନଷ୍ଟାଣ୍ଟ, ଏଗୁଡା ସବୁ ଇଲେକ୍ଟ୍ରନର, and variable ଟର୍ମଟା ରହିଲା n ସ୍କୋୟାର ବାଇ z.
ଏଇଟା previous class ରେ କରାହେଇଥିଲା ନା?
ହଁ ହଁ, ମୁଁ ଜାଣିକରି କରୁଛି। ଆଉ ମୋର ମନେ ଅଛି, ମୋର ଏତେ ମେମୋରି ଏତେ ଡଲ୍ ହେଇନି ଏପର୍ଯ୍ୟନ୍ତ, ମୋର ମନେ ଅଛି। ନା ମୁଁ ଖାଲି କହୁଛି ଠିକ ଅଛି ନା ନାହିଁ, ତୁମେ
Yes, sir. Yes, sir.
ଓରିଡ ହଉଛ, ସମୟ ଚାଲି ଯାଉଛି। ମୁଁ
No,
ତ
sir.
ମୁଁ ତ I could concede about more than 1 hour for revising Bohr theory, I mean hydrogen spectra. So you please don't mind to concede 2 minutes more for revision of this. Okay, then this R we got this. खाली ठीक ଅଛି ତ?
Yes, sir. Yes, sir.
Then ଆମେ proceed କରିବା energy equation. So some energy, total energy is equal to जो सेल रे इलेक्ट्रॉन अच्छी तर ग्राउंड स्टेट रे अच्छी, the total energy that it is possessing is sum of potential energy and kinetic energy. Kinetic energy is always half mv square, always. And potential energy ମୁଁ ଏଠି ଟିକେ ତମକୁ କହିବି ଯେ ଇଣ୍ଟିଗ୍ରେସନ ତମେ ଶିଖିନ, ହୋପଫୁଲି ଶିଖିନ, ଯେ ଆମେ ଫୋର୍ସ ଏନର୍ଜି ପାଇବାକୁ ହେଲେ force into distance ds f ds for a infinitesimal distance ds, ताको हमें integrate कर ले, हमें over the entire distance we get it. So हमें force नहीं थिले, हमें net work done and work is converted to energy. So this हमें force नहीं थिले, coulombic force 1 by 4 pi epsilon. I'm not putting the minus sign. So this z square by r square into dr. So if you integrate this and minus थाउ, minus टा प्लस ହେଇଯିବ ବର୍ତ୍ତମାନ ଦେଖିବ। So minus ଏଇଟା constant term ଟାକୁ ଯଦି ଆମେ ବାହାରକୁ ନେଇ ଆସିବା, z square ଏଇଟା, so it will be merely 1 by r square into dr. ଆମେ ପଢିବା ଯେ integration xn dx is equal to x to the power n plus 1 by n plus 1. So it is minus 2. R to the power minus 2 plus 1. That means R to the power minus 1 by minus 1. So minus 1 will be plus. So this will be minus 4 by epsilon z square by R to the power minus 1 by minus 1. The formula, if you put, you will know in your mathematics program about integration and its concept. So it a plus ହେଇଗଲା ଏଠି, ଏଇଟା minus 1 ତଳକୁ ଚାଲି ଆସିଲା, so it plus ହେଇଗଲା 1 by 4 pi epsilon. And to be with me, you should be a little bit conversant with mathematics. So it will be JD square by R. So what vanished? In the fourth equation, it was R square. In the fourth equation, it was minus. Now it became plus. And the denominator was R square. Now it will be R. But the constant term will be same. So this is the potential energy. Because all the work done while bringing the electron from infinite distance to, say, to the ground state, to the first cell, has been converted to potential energy. It is not taking into account that it is rotating with some kinetic energy which will be adding with potential energy. So this is the potential energy value. So let us once again write E total will be E kinetic plus E potential. So kinetic, oh no. It will be minus. Potential energy is always minus. So we don't take minus sign here. We take the magnitude of the force, but potential energy will be minus. So potential energy is always minus because energy is lost. I'm so sorry. So here it will be minus here. We take the magnitude of the force, the energy will be lost. So the work done will be stored as potential energy. The work done will be stored as potential energy because it's an attraction work. So the energy will be negative. It has lost. That means to remove the electron from there to the infinite distance, you have to give. It has lost. So its energy has decreased. Not it has gained energy, it has decreased energy. That is why it is minus. So minus. So this is half mv square, which is positive, and this potential energy minus 1 by 4 pi epsilon naught Jd square by R. Now look to the first equation from the centrifugal that we equated. First equation mv square. Now we shall write that mv square is equal to 1 by 4 pi epsilon. Half is there because kinetic energy half is there. So half into 1 by 4 pi epsilon into Jd square by R. I am taking it from equation number 1, which is waiting there. And now potential energy after integration we got this one. And minus sign is automatic because in attraction it will lose energy, so energy will be minus, not plus. Not that when you are bringing a positive charge to another positive charge, test charge is positive, here the test charge is negative. Usually test charge is positive. There will be repulsion. So you will be supplying energy. So when it will be coming to the first state, it will be having plus K. Supposing it would have been a positron, supposing a positron which is positively charged, and you bring it to the nucleus. So the energy will increase, not decrease. Because of repulsion, you are supplying energy, you are doing work onto the proton, I mean positron, whatever. And therefore, the potential energy is positive. तो मैं हाथ छाड़ दिला माने से मन को मन पड़ेगा. The energy has been stored, positive energy has been stored, so you need not have to do work. That positive charge will do work and automatically it will go out to the infinite distance. But in this case, तुम्हें ताकू हाथ मारी न से मन को मन attraction है चली by losing and losing energy, so therefore its value is becoming more and more negative. So it is negative set में है. So it x, it खाली x, it half x अच्छी. So there will be answer will be minus half 1 by 4 pi epsilon naught Jd square by R. So now it becomes 1 by 8 now. So E total will be minus 1 by 8 pi epsilon naught Jd square. And let us put the value of R, about which you are reminding me ଯେ ଆମର ହେଇଯାଇଛି ସେଇଟା ଟିକେ ମତେ କହିଲ ଡାକିଲ ସେଇ ଯୋଉ R ର ରେଡିୟସ ର ଯୋଉ ଏକ୍ସପ୍ରେସନ ଟା ଯୋଉ ଆମେ କରିଥିଲେ କେତେ ଏଇ ଭ୍ୟାଲ୍ୟୁଟା ଡାକ କେତେ ମ
n square h square
n square
Sir, n square h square.
N square
H square.
S square by
JD square
ZD square.
into pi meter. Pi m.
Hmm? Pi.
Sir, yes sir. Pi into m.
हाँ, S square N square pi m E square Z pi ଏତିକି ତ
Sir, m.
m। ସो ବର୍ତ୍ତମାନ ଯଦି ଉପରକୁ ଉଠେଇଦବା z ଟା ହେଇଯିବ z ସ୍କୋୟାର ଆଉ ଏଇଟା ହେଇଯିବ କେତେ ପାଇ ପାଇ ଗୋଟେ କଟିଯିବ ନାଇଁ ଏଠି ଗୋଟେ ପାଇ କଟିଗଲା ନା ପାଇ କଟିନି
Yes sir. Cancel out ହେଇଯାଉଛି।
ହୁଁ ତାହେଲେ କେତେ ରହିଲା କଣ ରହିଲା z ସ୍କୋୟାର ହେଇଗଲା n ସ୍କୋୟାର ରହିଲା ଏଇଟା ଭେରିଏବଲ ଟର୍ମ ଅଲଗା କରିଦେଲେ ଆଉ ଏଠି କନଷ୍ଟାଣ୍ଟ ଟର୍ମ ଆସିଲା ଇ ଇ ସ୍କୋୟାର ଆଉ ଉପରକୁ ଗଲା m ତଳେ ରହିଲା 8 ଇପସାଇଲନ୍ ନଟ୍ ଆଉ କଣ ରହିଲା अरे e टू द पावर 4 ऊपर आसले एठी e टू द पावर 4 ए स्क्वायर टा एठी e स्क्वायर संगरे मल्टीप्लाई हेले e टू द पावर 4 तळे कोन रहला 8
Sir,
इप्सिलॉन
already e square लिखिଛନ୍ତି ବା।
e स्क्वायर नो e टू द पावर 4 मु भूल लिखली तो
Yes sir.
मते
Yes sir.
मु भूल लिखली यू डिड नॉट करेक्ट मी सो इट इज m e टू द पावर 4 m गला गोटे e स्क्वायर और e स्क्वायर गुणा हे गले e टू द पावर 4 एंड n स्क्वायर तो ऑलरेडी मु लिखि सारची वेरिएबल टर्म भितरे z स्क्वायर लिखि सारची आउ रहिला कांस्टेंट टर्म भितरे 8 इप्सिलॉन नॉट आउ कोन रहिला
H square.
हैं
Sir, h square.
हां h स्क्वायर गोटे रहिला सो एटा कांस्टेंट टर्म टा रहिला एतिकी सो दिस कांस्टेंट टर्म इज कॉल्ड k जो k टा को मूलरू कहि देली से k टा होची वर्तमान एटा k yes correct अछि मु देखुथिली yes this is the k value minus k z square by n square so এই ইকুয়েশন টা আসলা k র ভ্যালু বর্তমান জানলো because in competitive tests like JEE NEET you have you will definitely get questions involving this k ভিতরে কোন কোন ଅଛି so k the constant is m e to the power 4 8 epsilon naught h square यार वैल्यू पुट कले 9.1 into 10 to the power minus 31 kg 1.602 10 to the minus 19 coulomb all SI by 8 epsilon naught 8.85 केते कहइतली देखिलो epsilon naught रो वैल्यू जो कहइतली is 8.8 minus 12 coulomb square per newton per meter square आउ h रो स्क्वायर होची 6.626 into 10 to the minus 34 रो square so all put in SI unit so the value is you will be getting 2.18 into the minus 18 constant and of course joule will be there everything will be cancelled the h value this Planck's constant because z is a number n is a number so k will be carrying the joule term so this mass is kg this e is coulomb and this is coulomb square newton per meter square and this is joule second so ultimately you can convert you will find the it will be coming in joule per atom this k value you apply your simple physics theory to find that for example newton into meter is equal to joule force into distance is work done is converted to energy so newton into meter is equal to joule So in the similar manner, you have to see that ultimately everything is precipitated to, is converted to Joule. K is this much. Now, this is done, said and done. Let us find the velocity equation. Velocity equation, again, you have to apply the quantization of angular momentum. Mvr is equal to nh by 2 pi, and from which v is equal to, this we have done. Just we calculate once again 2 pi mr. And using the r value, which again you have to tell me that nh by 2 pi m, what is the n square h square by, yes, how much? Z e square pi m. Z e square pi m. So here pi cancels, cancels. So, and what else cancels? One z cancels, one h cancels. So we are left with z by n, one n cancels. So this is the variable term remains, and the constant term, one z goes up, and e is remaining same, e square. And in the denominator, we are left with nothing. H, one H is there here, and everything gone. So this is the constant value. Let me check. Yes, we are correct. Z is, no, 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 no. We are, what happened to epsilon? We had some epsilon. अरे रे हम epsilon गला कुआडे इथर तो epsilon नहीं एनर्जी इक्वेशन रेडियस इक्वेशन रे epsilon टा तो कौन ओ epsilon गला कुआडे मते केही किछि कहल हाँ
रेडियस इक्वेशन तो हमर इप्सिलॉन बाहर नथिला
नथिला
नो सर
जीवो कुआडे
ये सर थिला हमें छाड़ी दे
जीवो कुआडे कारण हम इक्वेट करछु ओइ जो सेंट्रीपिटल संगरे हमर क्वांटाइजेशन ऑफ एंगुलर मोमेंटम को सो जीवो कुआडे तेणु मते सेते
प्रीवियस क्लास के में मिस कर देथिले
रोहित सलोटा छाड़ीथिले
ये
सो
सर ये
एन स्क्वायर एच स्क्वायर एठी इप्सिलॉन टाडी छाड़ीथिले मु तो रिवीजन कली तम मते ये कल ये जो 1/4 पाई 4 पाई टा काटिली इप्सिलॉन टा भी कटिगला सो एठी इप्सिलॉन टा एठी अछि सो इप्सिलॉन भ्यालु टाको आमे उड़ेई देले सेथिपाई आ गोटे कोठी उड़ेई देले एठी भ्यालु तो हम कले आउ थरे एठी पुट करिया को चाहू छे कोठी एठी नए नए
सर
एठी जो पुट कले आर रो वैल्यू जो पुट कले फाइनल एनर्जी रे एनर्जी इक्वेशन रे आर वैल्यू एठी भी इप्सिलॉन नॉट छाड़ देले तेणु जो कांस्टेंट टर्म टा रहिबो सेथिरे मध्ये इप्सिलॉन रहिबो केते रहला ऊपर ना तळे एटा तळे आसी गला तो सो इप्सिलॉन रो स्क्वायर आस जीवो हां एटी इप्सिलॉन नुए इप्सिलॉन एटी इप्सिलॉन स्क्वायर देखिलो m e to the power 4 divided by 8 epsilon naught square h square 8 हला के epsilon naught square देखिलो मु निजे भूल करूची निजे बाहर करूची तमे किछि कहून सो इटी इप्सिलॉन नॉट स्क्वायर एच रो स्क्वायर सेटा भाइबो 2.18 10 to minus 18 सो एटी पुणी वैल्यू पुट करो एटी आर रो वैल्यू एटी भूल हैला एटी इप्सिलॉन नॉट गोटे छाडिले सो एटी रहिले ताले इप्सिलॉन नॉट टा रहि जिवो को पटे वेलोसिटी इक्वेशन रे कोठी रहइबो सो जेड टाକୁ ତ ଆମେ ନେଇ ଆସିଲେ सो ଏଇଠି ଇପସିଲନ୍ ନଟ୍ ଟା ରହିଲା ଯେହେତୁ ଜେଡ୍ ବାଇ ଏନ୍ ଟାକୁ ଆମେ ବାହାରକୁ ନେଇ ଆସିଲେ ତାହେଲେ ବାହାରେ ରହିଲା କିଏ ଇ ସ୍କୋୟାର ବାଇ 2 एच इप्सिलॉन नॉट एतिक रहिला ई होची चार्ज 1.602 10 to minus 19 इप्सिलॉन टा होची परमिटिविटी ऑफ द मीडियम 8.85 into 10 to minus 12 कूलम स्क्वायर पर न्यूटन पर मीटर स्क्वायर सो एई वैल्यू टाको पुट कले यार मध्य वेलोसिटी इक्वेशन रो गोटे कांस्टेंट टर्म आसला 2.1 इट इज कॉमन into 10 to the power 6 z by n मीटर पर सेकेंड आउ যদি সেন্টিমিটার পর সেকেন্ড করিব তাহলে 10 to the power 8 ହେଇଯିବ ଏଠି z by n সেন্টিমিটার per second so so light ର ସ୍ପିଡ ବହୁତ ଦୂରରେ ଅଛି ଆହୁରି 100 times ଠୁ ଟିକେ ଅଧିକା ଏଟା 2.1 ଏଟା 3 ହବ 10 to the power 8 ଟା 10 to the power 10 ହବ ବା 10 to the power 6 ଟା 10 to the power 8 ହେଲେ ଯାଇକିରି ଲାଇଟ୍ ହବ but see even in hydrogen atom, Z is equal to 1, N is equal to 1 in the first cell, the electron is moving with such a tremendous speed, only 100 times, nearly 100 times lesser speed than the velocity of light or electromagnetic radiation. So how things will change now in quantum mechanics next time when we see it, we will prove that electron is not merely a particle, it is a wave. Because moving such a high speed comparable with the speed of light, speed of all electromagnetic radiation. So the itself is behaving like a wave. Wave mechanics ଆସିଯିବ इलेक्ट्रॉन टा पार्टिकल एपर्यंत भाबिथिले बोर थ्योरी रे वर्तमान ताकू एनर्जी इक्वेशन ठीक अछि बट ताकू किंतु ट्रीटमेंट करा जिबा एज ए वेव ए स्टैंडिंग वेव इज नॉट डाइंग आउट स्टैंडिंग वेव जब तक रहेगा चांद और सूरज अच्छा वर्तमान बिफोर वी गो लेट अस सीजीएस सिस्टम रे टे कर दवा एटा मध्य दरकार पड़िबो और इजी इजी सीजीएस सिस्टम रे तुमे घरे करिवो मु देखै देबी टू सेव टाइम तुमे पुणी आउ थरे करिवो इट्स वेरी सिंपल इन सीजीएस सिस्टम मु देइची एटा करिवो मु देइची सब जे रेडियस बाहर करो रेडियस इक्वेशन 0.529 एटा ताको ए नॉट बिली कहंती ए नॉट 5.529 एंगस्ट्रॉम अनुसार 0.529 into 10 to the minus 10 meter by 10 to the minus 8 centimeter taku angstrom. So this is A naught. The value is known to you. What is hydrogen atom ra first cell ra radius kehte He plus ra second cell ra radius kehte Li double plus ra third cell ra radius kehte so n square upare rahila z tole rahila z square no z teno seta ko put kariki tome bahar kari paribo you know greater is the principal quantum number greater is the radius kaina n ta depend koruchi ଟିକେ କିନ୍ତୁ z ଟା କମଉଛି z ଟା ତଳେ ଅଛି so z is the radius is inversely proportional to z because टमी रे प्रोटॉनिक चार्ज अधिका हेले attraction अधिका हबो so it will try to reduce the size of the atomic I mean the radius of the cell but n square term will dominate the n square term will dominate so the radius will go on increasing and increasing z remaining constant but if we compare with between one species to other hydrogen with He plus with Li double plus then we have to see the z term though remaining constant they are variable are 2 tar 3 are 1 tar 2 किंतु n term टा variable से अनुसार को कहार Li double plus रो को सेल रो रेडियस टा He plus रो आउ को सेल रो रेडियस संगे पाखापाखि समान ही पारे पाखापाखि नो एकदम समान ही पारे so that देखो ना एटा नहीं एटा समान हेनी मु जोटा देइछ अलगा अलगा हेछि सेमती वेलोसिटी पचारछि हाइड्रोजन रो थर्ड सेल रे इलेक्ट्रॉन गले वेलोसिटी कोन सेठी कोन z ऊपर रहिला n तळे रहिला सेठी n स्क्वायर ऊपर z तळे एठी z ऊपर n तळे you know larger the distance less is the attraction and the velocity will be less दूरता बढ़िला किंतु वेलोसिटी कमिला तेणु the principal quantum number is inversely proportional to velocity now CGS system is very simple k is 1 everything remaining same but the Coulomb's law of k F is equal to k into q dash by r square k ta 1 by 4 pi epsilon thila कोथरे ना SI रे किंतु CGS रे K टा 1 तापर सब कर चलो सेमती mv स्क्वायर बाहर कल इक्वेशन v स्क्वायर बाहर कल इक्वेशन 2 क्वांटाइजेशन ऑफ एंगुलर मोमेंटम रु v स्क्वायर बाहर कल ताकू इक्वेट कल आउ 1/4 पाई इप्सिलॉन नाही तेणु रेडियस इक्वेशन एटा बाहर गला ता से कांस्टेंट टर्म को अलग कर देले a स्क्वायर बाय एटी इप्सिलॉन नॉट नाही এই जो 4 पाईटा बाहरला एठू नॉट विथ दी 1/4 पाई इप्सिलॉन नाही तेणु एटा बाहरला एटा भी a नॉट हला वैल्यू भी एका बाहरिबो किंतु एठी डिफरेंस होची कोन एठी इलेक्ट्रॉनिक चार्ज टा 1.602 10 to minus 19 नुए 4.8 into 10 to minus 8 स्टार्ट कोलम सो 10 to minus 10 स्टार्ट कोलम सो एठी पुणी एनर्जी इक्वेशन हाफ mv स्क्वायर एटा इंटीग्रेशन कला पर माइनस जेड स्क्वायर बाय आर तेणु एठी भी शेयर होइला सेटू इंपोर्ट करा हला एठी भी शेयर होइला आर रो वैल्यू पका हला एठी बाहरला यार कांस्टेंट टर्मटा हला 2 पाई स्क्वायर me4 बाय a स्क्वायर तार कांस्टेंट टर्मटा बाहरथिला कोन आमे जो बहुत कष्ट करि कि आज करेक्शन करथिले तार कांस्टेंट टर्मटा बाहरथिला m e to the power 4 divided by 8 epsilon naught square by a square यार CGS रे इप्सिलॉन नॉट नाही कि 4 पाई नाही तेणु एठी एनर्जी टर्म रे बाहरला कांस्टेंट टा k टा 2 पाई स्क्वायर m टा होची 9.1 into 10 to the minus 28 ग्राम फिर minus 31 kg यूज करथले e टा होची 4.8 into 10 to the minus 10 स्टार्ट कूलम और ESU h होची 6.626 into minus 27 अर्ग into second तो ताकू कले सेया बाहरिबो एटा 10 to minus 11 अर्ग पर एटम बाहरिबो आकू कन्वर्ट करी 10 to minus 18 करि परिबो सो ए डेरिवेशन टा भी दरकार हो सीजीएस सिस्टम रे भी गोटे गोटे परीक्षा रे क्वेश्चन पचारुचंती जे एग्जामिनर जो क्वेश्चन सेटर सी भाबुची याउ ये एसआई सिस्टम रे डिफिकल्ट हे जिवो इप्सिलॉन नॉट कोठी तार दरकार हबो दरकार नहीं ताकू सीजीएस सिस्टम रे दियो तो ता पई आर एक्सप्रेशन टा अलगा n स्क्वायर बाय z टा कॉमन बट द कांस्टेंट टर्म इज डिफरेंट सिमिलरली एनर्जी इक्वेशन रे कांस्टेंट टर्म इज डिफरेंट सो यू हैव टू in your copy you have to write you have to deduce this from the very beginning concept is same and go to the final and same thing तार velocity equation भी बाहर करियो ता देरे मध्ये कांस्टेंट अलगा आसीबो बट अल्टीमेटली सेम वैल्यू बाहरियो से 10 to the 6 प्रथम बाहर थिला ताको हमें सेंटीमीटर कलु पछरे 10 to the 8 कलु किंतु एटी 10 to the 8 प्रथम बाहरियो ताको हमें मीटर करियो 10 to the 6 करियो सो एटी कह देछि इलेक्ट्रॉन रो चार्ज केते आउ H ର constant केते mass of the electron is 10 to the minus 28 नबो so with this we conclude today's session next time we will be completing Bohr's theory within 30 minutes out a spectral problem अछि spectral transitions problem टिका अछि सेटा सारी की हमें quantum mechanics को जिबा any question you want to ask No? Yes or no?
No, sir.
Okay.
No, sir.
If you have no question to ask me now, you feel free to ask me in your WhatsApp message or
Yes.
in Telegram message. Bye for now.
Pranam, sir.